Hey everybody, how's it going? Happy Tuesday morning or evening or wherever you might be. How's it going? I hope it's going well. So, welcome to my live Cody stream thing, my third one ever. And today we're going to be continuing where we left off. So I'm going to jump over to that slide deck thingy and I'm going to talk a little bit about what we're working on today. So, just a sec. Here's a quick summary of what we were working on in a slide deck form. We are working on a program to make animated GIFs from pictures taken from a whole bunch of cell phones. This is a demo for a work project I have called Google Cloud Spin. If you'd like to learn more about it, you can go to this Twitter handle, or I can go to this page myself, and I can show you there's a whole bunch of different tweets out there. And obviously, this Twitter stream has existed for a couple of years, which means this project has existed for a couple of years, which is great and all. We've actually built it a few years back, but it has some limitations that make it very difficult to set up and maintain. So I'm currently working on kind of a re-implementation project where we use some of the more modern features available on our platform and make it easier to deploy so we can do it at more places and make it easier to kind of like hack on and make better features. Like there's some changes I want to make. I want to make the GIFs a little smoother, some stuff like that. But before I can get there, I have to kind of re-implement what is already there. And let me get this off the screen. This is a summary of how we're going to implement it. We're using Google Cloud Functions and lots of Firebase stuff, because I love hacking with Firebase stuff. It is a wonderful tool, platform for building prototypes, not just web application and mobile apps, but all sorts of stuff. And here's the architecture we're kind of building out right now. We're building one specific component right now. The component we're building is the gifing component. So I figured I would start with the most exciting part, the middle part, and then work my way out to the edges, and then start incorporating some other work that some of my peers have been doing, including my former intern who just left to go back to school this week. So Hassani, it was great working with you. I hope their studies this year are awesome. I hope to see you again when you finish your degree. Anyway, Hassani did a bunch of work on the other parts, and I kind of started on the part he didn't have time to work on, which is taking a whole bunch of still images that have been extracted from the phones and turning them into one fancy, pretty GIF. And what we're doing is we're using one of kind of the reference designs from Firebase and Cloud Functions and storage, which I just grabbed this picture right from the documentation, which is like linked right here. Boop. You can see it in the docs. So there's actually some kind of reference designs for solving different problems with Cloud Functions and Firebase. And one of them is taking a single image uploaded from a mobile device, using a function trigger from storage, and then converting it into a thumbnail and writing it back to storage. So you can see it on other mobile apps. That is very similar to what I need, except instead of a thumbnail, I need an animated GIF. And I'm starting from many source images, which is convenient because I can just start working from the sample. And that's what I've been doing for the last couple sessions. So if you'd like to take a look at what has happened so far as I hacked on the microservices and played around with Cloud Functions, take a look at, it's on YouTube actually. They're on my YouTube channel. They're also on Twitch. But you can find them if you go to youtube.com/c/mimming. There's a playlist of the live coding Twitch streams in the past. So if you'd like to see me fumble around for almost an additional 3 hours as I start to learn node.js, which it turns out I didn't really know that well, you can go to YouTube and check them out, or watch them here on the videos tab. Anyway, getting back to what we are working on today. Where we left off is we figured out how to make GIFs on the command line and do that thing from node.js. Those were in session 1. In session 2, we got them sourced from a cloud storage bucket, and then we were able to make the GIF and then stash it back into that bucket. what we're going to do today is, it turns out I didn't actually know promises. I kind of knew I didn't know them already, but I had been able to fumble through some things in the past. So I took some additional time while I was offline to tinker around with them. Now I know them a little bit better. On like the 1 to 5 mastery scale now, I'm probably at about a 2. So we'll be moving a little bit smoother through them this time. So I'm going to fix some of the mess I created last time. Then we're going to wire it up to the real-time database, which is what's going to be triggering the creation of the GIF and signaling the fact that the GIF has been created and uploaded. Although I could use storage triggers for this also, I think I'll use real-time database triggers, just because it's easier to interact with some of the other components that have already been written. And then finally, our GIFs do not load in Photoshop for some reason. So if we have some time left over, I will poke around at the GIFs that are getting created and see if there's some ImageMagick flags or something I need to give to it. So yes, there we going. So I guess without further ado, let's get into the code and actually do some of this stuff. So we're going to start with cleaning up that hard-coded disaster I created last time. So here is the code. Let me make it take up most of the little screen. Let me get my terminal up over here so you can kind of see everything I'm working on. That kind of works. Why not? Okay, I might be dragging some stuff around to fit the screen better, because window management while streaming is tricky because there's this little camera in the corner messing with everything. Silly, isn't it? Anyway, getting back to the code at hand. This is where we left off. We had this like, so what is going on here? So it's a node.js function right now. Right now it's just a plain old boring node.js function. It's not actually wired into Cloud Functions for Firebase yet. Accomplishing that will just be changing the signature so that it's a trigger, but we'll get to that later. First, we need to clean some stuff up. So we have some like stubbed out data that would normally come from the Cloud Functions trigger. We have some data getting shuffled about into temporary variables. We grab a handle on a temporary directory so that we have a place to do some of our manipulations of those images. Because ImageMagick is actually a sub-process that's getting called basically by doing a command line call. Then we are doing this terrible series of promises right now where I'm downloading pictures one at a time and using a chain of promises. So this is where the stuff I learned actually starts to be useful. So what I learned is promises are really just kind of like an execution of a background thread that it starts running immediately, which is pretty cool. And then they chill out and wait until they a method upon them, like a then or error, are called. And there's a few different things you can call afterwards based on their status. And then kind of iterable data structure. Oh wait, I have to go back to code. Yeah, I can stash them in some kind of iterable data structure, like a list, and then I can sync on all of them at once, which is kind of a neat thread mechanic. It's pretty similar to other thread mechanics. This has a standardized API of doing those background threads, which is pretty cool. It is a neat invention. I probably should have paid attention to it when it became popular 2 years ago. But can't keep up with everything. Gotta wait and pick a few things, right? Anyway, so what we're gonna be doing is we're gonna do iteration. Right now we have 4 images numbered 1 through 4. These will actually be coming in, like the number of images will be coming in on an input. So I'm gonna stash them in a thing here. So where will these be coming in? Yeah, the number of images will just be specified. It'll be coming in the request object from the trigger. So const num frames, and we'll just do 4 for now because we have 1 to 4. In reality, it's probably going to be 0 to something later on. So for let I equals 1, because we're starting from 1, because the thing is weird, I is less than or equal to 4, because there's 4 frames that stop at 4, which is kind of an awkwardly structured for loop. Yeah, we're doing the old iterator style for loop because Yeah, there's not an iterable data structure for us to consume. We're just counting to 4. Yay! Then what we're going to be doing is we're going to make a collection of promises. Let downloads. Call it frame downloads. Now we're going to make that a new list. And what we're going to do is frame downloads.push. We're going to push a bunch of these promises onto it. Each one of these promises is one of these downloads. So we're going to grab this. And I don't know if that's the... Yeah, half of the time when we code, we just spend formatting code, right? Does the auto formatter care? Auto formatter has no opinions about this line. So this is going to be, so right now we still have a hard-coded session 1, which is coming from up there. And then we have the file names coming down. And we have our frame number, which is just I. So that'll get jump 01, and then we want to download them to our temporary directory. And now we have this new OS tempter up here. So that's going to be our base. And that does not have a leading slash, so we need a slash in there. And we're just going to call them, we're going to preserve the file name. Which works fine. And it's the ith frame. And this should just download all 4 of them. And like, so the moment I push these onto the frame downloads, they're actually already running, which is kind of cool. And then what I can do is use Promises has this cool barrier where we can sync a collection, an iterable set of promises, which is cool because you could do it to kind of an arbitrary set, which is similar to how I used to do threading back in the day in like C++ and Java and stuff. But having a standardized API is kind of slick. It reduces that cognitive load because multi-threading development is complicated enough. Any way you can reduce the cognitive load is a huge benefit. So you get fewer, harder to debug errors. Yeah, and okay, so what we want to do is, and this is just a call on the promise. And this takes, as you saw there, it takes an iterable set of promises, like this thing, because this bucket file download method returns a promise. And then we can do we give it an arrow function with no arguments coming in. Okay, so what this will do is it will download all the things, or rather it's waiting, it will continue execution after all the things have been successfully downloaded. Then when here we will be doing the GIF creation, the animated, and this is going to be another little, let's see if we can unwind any of the hard coding here. So we're going to create the animated GIF, and we're going to do another arrow function. And finally, if the GIF has been created successfully, we will upload it back to cloud storage. And we've now replaced this monstrosity with something slightly less awful. This closing bracket is way down there. I don't like that being down there. I'm going to move that up closer to my mess. Okay. So now we still have a bunch of hard-coded stuff in here. We should probably unwind. Let's add some new lines to this to make this a little bit easier to read. Okay, that's a little better. So we have a 4-frame GIF, and the source images are all broken now because I changed the file name. It's all tempter relative. So let's just copy the code for creating that up there, and then clean it up. And these will be hard-coded for now. What I could do here is figure out this section is just going to be the number of frames coming down, and I can calculate that. Because what I want is I want one long frame at the beginning, a bunch of fast frames. These are 20 centiseconds. This is 100 centiseconds because it's hundredths of a second. Yeah, it was weird like that. And then we finish with another 150 centisecond frame at the end. So we'll just hard code these for now. Well, later when we actually have this starting to be wired up and getting real data from the other parts of the chain, we will copy them, or we'll make it so it actually like defines it properly. So hard coded all those things. We have frame 2, we have frame 3, we have frame 4. Yeah, so what this will do is whatever the highest number possible frame is will end up here. We'll calculate a bunch of frames to stash in here. So we'll be building out this list here. I'll add a to do to that. To, based on number of input images, construct the argument list, ImageMagick. Oh, and there's one other thing we wanted to do, which I'll do after this, is I want to the convert command is what all the samples use. I'm not sure why they all use that, but I'll switch to using that too. Instead of using the magic command with the convert sub command. Okay, so let's add a log statement here to make sure stuff has been downloaded. Stuff downloaded probably. Time to try and GIF. Downloaded probably. GIF time. GIF time? Got a 1 there. And then we should have a GIF. Where should the GIF be? Oh yeah, this is still wacky. We have our operating system temp directory, which is a much safer way to be doing all this stuff because it will work locally and in the cloud. Let's call it spin.gif. Sure, spin.gif, which means that this will be in the same location. So one of the things I've kind of noticed about using promises and like the kind of customs people do around them, you have kind of a bunch of essentially global variables across your threads up here that you use for communication. I guess it's a good enough trade-off for the fancy multi-threading. Because I mean, dealing with those kind of pseudo-global variables, or at least global within the scope of all of this thread execution, is probably less error-prone than the multi-threading mess. So, okay, so this is the destination bucket, which is giffizer gifs. We have 2 buckets, which we can see. console.cloud.google.com. Let's go take a peek. Let's make sure we still have those 2 buckets. We're going to go on over into storage. Actually, almost always just type to find things because it's faster. Typing is faster than reading for me. So we have giffizer gifs, giffizer source. We make this legible to you. Giffizer source. Okay. Can I close that? Yeah, I can. Okay, so giffizer source. There is our GIF. Let's delete it so that we know our thing is actually working. We're going to go back to buckets and we're going to look at our source images, which are up here. Session 1. They're all up there. We don't need to delete those because we're going to be pulling those in. Okay, so it looks like our environment to do a test run works. I just typed like 30 lines of code, which means there should be some catastrophic problem. When I run it, let's find out. We're going to give it a run. Let me make sure you're still in frame. And it's running giffizer, stuff downloaded, GIF time, you should have a GIF? Wait, did it just work? That would be amazing. So we reload this page because it does not update in real time. Oh my gosh. Hey, it totally worked on the first try. Well, by first try, I mean the refactor was successful, which is still a big feat for me. I'm going to celebrate with some coffee. So today's coffee mug is coming to you from Cafe Du Monde. I lived in New Orleans for 6 months at the end of last year, end of 2016. And I bought this cup there on my first day there, because when I first moved there, I had no cups. So I bought one at a famous coffee shop. New Orleans is a fun place. Anyway, back to the code. So our spin.gif worked. We have this working. This is cleaned up. I can take this catastrophe of not really knowing promises and delete it. I have all this stuff too, which is now no longer useful. It's in source control anyway. And we have reached the end of one of our tasks. which is clean up that terrible hard-coded mess. So I'm going to strike that through, which is under font. I think it's under, there it is, strike through. There's no hotkey for it in Keynote, so I have to go find it by hand. Oh yeah, so that is now struck out. So we are going to move on into wiring it up to the real-time database, which will be where the triggers come from. Just because the triggers are more expressive there, and that's how the mobile apps are currently designed to send information downstream. Okie doke, so let me drag this off. And since we're at kind of a, not a stopping point, but a working point, I'm going to check it into Git. I have a yay.js from my experiments earlier. Let's remove that. Gonna do a status. We're gonna add all the things. Gonna commit. Cleaned up a catastrophe. Disaster? Disaster of terrible promise code with stuff that is slightly less disaster. But probably still embarrassing. Cool, it is committed. And there's nowhere to push it to because this is just a local repo. Eventually, this code is going to get pushed into the Cloud Spin repo, which I might do this session if we have time, because we're making good time. I have a whole hour. Okay. So, since we're at a stopping point, I'm going to blab a bit. Hi, everybody. I don't know if anybody's actually watching right now, but if you are, feel free to use the chat. I love hearing from you. I love advice, encouragement, criticism, comments. I don't know. Talk to me. It's fun. It's social. And let me know if you're enjoying what I'm working on or if you want me to work on something else. Love hearing from people. Okay, so back to the project at hand. We are now going to wire it up to the real-time database. So let's go over to the Firebase console. We have our giffizer project. And we have, so far we've been tinkering around with storage, which mirrors the buckets for, so there's actually a special bucket I probably should be using. Because the storage on Google Cloud Platform and Firebase are mirrored. Like the Firebase storage is backed by Google Cloud Storage. So like if I upload a file here, like, I don't know, let's upload a GIF. Where should I find that GIF? I'm going to download one of the source images. So if I go back to the browser, I download one of these source GIFs. I think it goes to a special bucket. Let's download it to my desktop. Boop. Because I am not going to upload any of my dinosaur GIFs yet. And if we go back to here, we want to go to, yeah, here it is. Upload a file. Gonna grab that one and we upload it. Where does it end up in cloud storage? New multi-bucket support. That's what I was looking for. Add bucket. Here we go. I wanted to import these because there's a special bucket that it uses by default. But what I really wanted is, let's take a look at the bucket it uses by default, which I think is it giffizer.appspot. There it is. Giffizer.appspot is the one it uses by default, which is the host name of this project. Because all projects kind of get their own host name, which is the project name, the project identifier.appspot.com. But I want to be using these buckets. So I had to use a new handy dandy feature to make them available to my Firebase land. Giffizer gifs. Security ruler set to private. Yes, I know that. Because I would not want anybody tinkering around with my stuff while I was working. Fortunately, this UI element's a little bit broken for very short lists. That's kind of funny. I'm gonna grab a screenshot of that because that is hilarious, and I should probably try to get that. Oh, it's when the screen is super narrow. Oh, that is cool. Okay. I'm going to grab a picture of that because that is just too funny. Wait, I already have this recording, but a GIF will be easier to send to other people. OMG, the bucket list is too small. Because it's good to be a good coding citizen and share all of your bugs with the people who write the software you're working on. Yeah, like this is hilarious. Because there's actually 3 buckets there, so I should be able to get down to the last one. But like the UI just does not work. Okay, so I grabbed the GIF. I will use that to file a bug later. Where is my giffizer source GIFs? Anyway, back to the action. We want to wire this up to the real-time data. So we've just been playing around with storage before I got distracted. But there's also this cool feature Firebase has called the real-time database. And the cool thing about the real-time database is that it is like the client libraries handle a lot of the heavy lifting of like caching and all the real-time synchronization stuff, and a lot of the thread stuff also. So it makes your life a whole lot easier when writing applications that need real-time updates between each client. And it also has a really cool expressive security rules language that we'll be using pretty heavily, which right now is minorly locked down. It's locked down enough that none of you can tinker with me while I'm working. So back to giffizer GIF. So one of the things about doing the real-time database is you have to design with these security rules in mind. So I'll dig into that. That's going to be a whole show on itself. But for now, the TLDR is you want to build pretty flat databases because each real-time database is a big old tree. It's a big old ball of JSON, so it's a big old hierarchy. But you want it to be relatively flat, and then each kind of thing, each data type, kind of has its own root node. So we're going to have a few different root nodes here. I'm just going to kind of like fixture out some data, and we're going to be using this web interface or maybe like a curl script to trigger these events. So a given, and some of this is based on prior design I did with other people working on Cloud Spin v2, particularly my intern Hassani, who did some amazing work. So I'm re-implementing some of the stuff he did today. So for a given Cloud Spin, it's a multi-tenant application that can actually have multiple Cloud Spin environments running at any given time. So there are different rigs, and normally rigs would be created by like a controller app at the time of creation. But right now, that's I'll just be hand coding them for now. So we're going to make a fake push ID. So this is going to be rig ID. So each rig has a rig ID. Foo bar will be our fake rig. So that would normally be what's called a push ID, which is an ID that the clients can create that are these monotonically increasing globally unique identifiers. We'll just use foo bar for now. And then within each rig, there's going to be some values. A rig will have a display name. And this one will be awesome. And enter. Each rig is also going to have should it have a phone count? Maybe. We'll stick that in there for now. Camera count. This is the number of cameras that should be expected to be there. So our current one, let's just say 9. It's usually an odd number so that you have one centered camera. Okay, so we have a bunch of different rigs, and we have this rig ID, which we'll be using to keep track of all the different rigs. We have a different root node, which is a session. And sessions are organized. Session is a single time when someone hits the camera taking button, and we record a whole bunch of different video clips and that kind of stuff. These will be organized by rig ID. And then within each one, there's going to be another push ID, which is the session ID. And then within each session, what is in each session? So each session is also going to have, I don't know if it needs anything. I think it just needs a session identifier. Yeah. Okay, so I can get rid of this. And then we'll just call it, sometimes you just need to store IDs in Firebase, and then you just use a Boolean value. So we have session identifier is true. So this will allow me to find the different session that's currently occurring. So this is where I'm going to store the currently active sessions. So what is going to be the triggering event for this? So rig, we're going to need a cameras node. So camera states. So camera state, which is going to be each rig. So the camera state is kind of the state machine for each camera in that rig. And that is going to be organized by rig ID. Not a big shock. And then within that, there's going to be a bunch of different cameras that are doing their thing. So these are going to be a bunch of different push IDs. And they are going to have their state, which is going to go through a state machine, which I haven't designed on screen yet, which we'll probably spend some time designing. But for now, I will have idle. And this is how, like, because one of the big things you run into when you have like 19 phones connected to Wi-Fi potentially is they kind of drop out connectivity sometimes. So in addition to keeping track of like when photos occur, this is also the mechanism we're going to use to see if phones ever drop out. Which means if they lose connectivity, this node is going to vanish. And then, I actually want to change that one. I want to put a padding 0. If phones ever drop out, then we'll know, and we can have the rig say like, hey, a phone is broken, somebody should go fix it. So this means that they're connected and idle, and they're ready to go. And this is a rig with, we'll just do a rig with 5 cameras. Okay, so we have 5 cameras. They're all idle right now. That's how that rig is going. The rig itself also has a state machine on it. Like the rig is capturing, the rig is not capturing, and that's actually how the cameras decide to take their action. So the rig itself also has a state. In this case, this whole thing is idle. So right now we have the camera count is 5. We can actually use, Firebase has these client-side transactions we can use to keep this node synchronized with these nodes. And these nodes going out of sync is actually going to be one of the signals we'll use to know when something is malfunctioning in that whole rig. Yeah, isn't getting a whole bunch of computers to collaborate a lot of fun? It can be tricky, but it's always interesting engineering problems. Even if you're out, because like essentially what we're working on is kind of like a distributed lock, which is a hard problem. And fortunately has lots of nice computer science solutions too. So we have a session. Session 1 is true. Session has more going on. So this is actually where the interesting things are going to happen. So these are all idle. They've just finished capturing a session. Our session is session 1. And session 1 actually contains other information. So I don't want to delete it. I want to add. So I am going to shuffle some stuff around so that session 01, and it is going to have some metadata there also. The session has its own state machine. Wow, this is like 3 overlaid state machines. This is just nuts. That's because while the camera rig is capturing people getting their picture taken, we can still sequence through all of the video processing. Like these can be done in parallel, and having another separate state machine is something that will help us accomplish that. So there's another separate state machine, and this one is like goes through the state of, so it'll kind of mirror the last state that all the cameras have collectively hit at the same time. So we have session 01, state uploaded, and so upload has been successfully completed. I can delete that. The reason I have this kind of like wonky data here is because you can't have empty nodes in Firebase. They just kind of disappear because JSON doesn't allow empty subtrees. Okay. So I stuck that there so that like this stuff would remain intact while I shuffled around session 1. So session 1 has been uploaded. session 1 contains, so do I want to point to the bucket or to all of the different still images? Let's just do frames for now. And then what's going to be in frames is, let's just do bucket for now. I can do a stat on bucket path. And then this is going to have a bucket path. Actually, I don't even know if this is really necessary. Session 01. And this is actually in the giffizer source bucket. So I don't know if this is necessary because this is just derived from this thing. These should match, because what I'm going to do in practice is this directory in the bucket is going to be just this push ID, which means it's going to be gibberish when it's running, but right now it just contains the word session. I guess the bucket path there, that might be redundant information because I can probably infer it from the rest of this information here, but that's okay. I'm going to roll with it. So when this one switches from uploading to uploaded, that's going to be my trigger that I should go slurp all of these things down. So I'm going to go and giffizer source. I'm going to rename this. Can I rename this? I don't know if I can actually rename it. I think I have to just recreate it. I can probably recreate it or probably rename it with the API. But I'll just recreate it. Yes, create. Then I will download all these files. But how? Okay, I'll do it the stupid way. I'll save them all to my desktop because I did not keep a copy of them handy. Actually, can I just download from here? I feel silly now. I remember there being an easy to see download button. Oh, there it is. Nope. Why? Why? We will do it one frame at a time because tinkering while you're streaming is tricky. Because cognitive load. Yeah, that's one of the taking a meta sidebar. Coding while streaming is an interesting exercise. Because you're spending a little bit of time trying to make sure you keep the stream somewhat interesting. And, oh gosh, I created a mess. I created a huge mess. Okay, and you're also spending time making sure you're not leaking out too many API keys. So you end up using cruder tools than you normally would, which is not always a bad thing. But it is a different experience for sure. Okay, so now I can delete this session 01. So my little script is going to break because I changed the path. So I'll have to change the most hard-coded paths. And now I have this directory, or this path. Go back in here. At least drag and drop upload works really well. Hey, isn't that cool? Yeah, that's not, like, it took me a while to figure out that I could actually do that, but it's pretty fast. Like, it's a pretty efficient upload. I've uploaded giant chunks of data that way. And it's worked pretty well. Okay, doke. So we have those up there. We have our 4 frames in there. Then, how does it know which frame is in what position? So, these should probably be, the camera identifier should be in these. Which means camera state. These cameras, how do they correlate to position? I think they're going to be numbered. It's going to be interesting. These might just be indexed by number. I'm trying to remember the design that we've already done because we have not done a full end-to-end test on the implementation. And before you do that, there's always some kind of gremlins to riddle out. Okay, so these might just end up, the image names might just end up being the camera names. That would actually make a lot of sense. So these file names are probably going to be derived. So I am so we're going to go rename them to what we expect the identifiers to kind of be. So we're going to rename them to what we expect it to be. So it's probably going to be, camera 01, because there's up to 99 cameras. And then it's going to be some kind of timestamp identifier, which is probably going to be like an ISO timestamp or maybe a CTime. ISO timestamps are nice because they actually sort 2017, 0, what is it, 0815, and then the time. It is currently 1117. Oh man, these are going to be ugly timestamps. So I'm probably going to have the full ISO timestamp in there. But I can probably just do a shorter version while I'm hacking around. So we'll just do minutes, seconds. Milliseconds. So now we know the camera, and the camera identifier is going to tell us kind of the position within that physical, rig. So the camera identifier is going to give us the position within the physical rig, and then the timestamp. Because what's happening is we're actually using the videos, and we're extracting frames from the video. So we're actually going to be doing a whole bunch of these GIFs created in parallel, so that people can pick their favorite one. So there's a question. Oh my gosh, someone's watching me. Hi, Phoenix Uprising. On the right side of the files? I don't really understand your question. So this one, jump 02, is going to come from camera 2. And if I used a real shell, I could probably do this faster with like a proper script. But I still use bash like some noob. I should learn like corn shell or Z shell so I can be cool. Right. Okay. So let's purge these. Then we're going to go back to the fancy pants. Just brought a preview. So GIF frames. Copy all those up there. They're up there. Okay. So now we have things that kind of at least resemble. I think those timestamps are going to be longer in production. Oh, someone said stream delay. That was from when you were wondering, when you were downloading many files one by one, the vertical dots on the side of the file line items. Oh, you can rename and edit permissions and copy and move there. Yes, there's the hamburger menu, my favorite design pattern. Or I guess the dot's a different kind of menu. But yes. I usually slurp them down with the client library. Anyway, so those files are all uploaded. So now we're going to be inferring these from the state of the real-time database. So let's go in. And when this state switches to uploaded, that is when this is going to trigger our function to go slurp down all that stuff. So we can actually trigger it from the web browser. So let's go through. So we want to make a function. So instead of just having some like rando node.js trigger, we're going to change it to be triggered from Cloud Functions. Exports. Giphy eyes. And except it's going to be a different kind. Instead of being an HTTP trigger, Firebase Cloud Functions. Because why remember how to do something when I can just copy and paste off of the internet? So I'm going to go back to the documentation for introduction. What can I do with Cloud Functions getting started? Let's go back to the getting started guide and see if there's a signature that I can just copy. So scrolling all the past stuff I already know. Am I in the right directory? Cloud Functions, I am. How to deploy them. Here it is. This is a database reference function. So what you do is a functions.database.ref, and you give a path of the real-time database, and then you trigger on a certain event, like an on-write event. So that's what we're going to do up here. Boop. And what's really cool about these listeners is they're a little bit more expressive than the ones you get from the regular client libraries, and that you can put wildcards inside here, which then get populated when the function runs. So we want to trigger, but we don't want to trigger off of a message push. We want to trigger off of session identifier, session rig identifier, session identifier. So we want to go to rig ID, session ID, and then we get back the rest of the event here, which has our state. So we want to trigger, do we want to trigger whenever there's a write here, or do we want to trigger whenever there's a write to state? Let's trigger whenever there's a write to state, because that will kind of give us a slightly narrower band of stuff we're working on. So now whenever there's a write to the state location, we're going to get an event. And I could even go further. Could I go into that value? If I design the database a little bit differently, I could even trigger so that it only triggers when uploaded has occurred. But I don't think I'm going to go that far. So let's just do the inspection thing where we take let's comment out all the things and just deploy a simple kind of like hello. Let's just log. Let's make sure it's triggering at that location after we deploy it. And let's log console log event. Hello functions. Let's make sure it works at all. Oh, that's not a reg ID, that's a rig ID. And then let's log out all of our variables. So that we can see them. Oh, actually I have to extract these. Because these are not just they're not just magically instantiated. There is something I actually have to grab them from. Where does push ID? Do they have it in this example? They do not seem to have it in this example. But I want that push ID. Okay. Braces around parameters, wildcards that are matched to data in the callback. Does that mean it's in the event payload? Maybe. Uppercase, original.to uppercase. Oh, event.params.push ID. There's the rig ID, should be in there, and the session ID. And then the event, the actual stuff I want from the event is going to be in this original. So let's do our hello functions at the very beginning in case we cause some catastrophic crash right away. Okay, so this is just kind of like making sure that the function's kind of running in some somewhat reasonable sense at all. We're dumping out the event value, which I think is going to be the data coming back from that. This should probably be single quotes. Because coding style is important. Okay, so let's deploy this function. So we are in gif function, Firebase deploy, which will deploy all the things. Credentials were incorrect. Oh my gosh, that means I need to go through an OAuth flow. I think you all know what that means. I'm going to do Firebase. We're going to unauth. Oh, my Firebase client is out of date. I'm not going to update that right now, though. So we want to do Firebase. We want to deauth, which is log out. Because I have to go into super duper hacker mode, and I'm going to authenticate because I don't want to leak out a bunch of tokens. So I'm running the Firebase login command, which is going to give me a super secret URL that I never want to show anyone else in the world, because it would allow them to hijack my account if they were to see it, and if they could type really fast. Okay, I am all authenticated now. Let me just make sure about that. Okay, we are switching back to live code and view, and yeah, so now I am authenticated with giffizer, and I'm an owner of it. So we'll deploy that again. We're going to do a little dance. We only have one tiny function, so this should go pretty fast. But if you have a lot of functions, this can actually take a little bit longer. Missing parentheses after argument list. I have a syntax error, which is not that shocking. Oh, that's because I commented out. Remember I said I like to keep this up near where I'm actually coding? There's a reason for that. Because, you know, we're coding live by deploying to our Firebase. So it is deleting the hello function I removed, and it is creating the function giffize. So we want to get ready to go see where that's going to be going. So we're going to go into functions, but I want to keep a handle on the database too. So we're going to be switching back and forth between the database and, which will be in this session 1. We're going to be changing the state of this thing. And then our functions, we have our giffize function, which is already up there. We're going to look at the logs. If we had multiple functions, we'd want to look here. And now we're going to want to trigger an event. Uploaded. So we're going to have our thing move through the state. Did it trigger any logs? No. Didn't even break. Oh, no, there it is. Okay. So it took 507 milliseconds, probably because it's the first time it's executing. And hello functions, uploaded. Cool. Uploaded. Console is not defined. Because I can't type and I ignore my little yellow squiggles. But where did that uploaded come from? That's interesting. Is that the... Oh, okay, that is the state. That's the event payload right here. So let's actually mark that out. Stuff. Okay, this is the new state, new session state. Let's kick that function back up into the sky. Boop. Deploy it again, and it's fast enough that I can just code against the deployed version instead of trying to rig out the local dev environment, which does work. But the local dev environments for the built-in functionality is limited to just HTTP functions. So you can kind of mock it up, but if you're making functions that are triggered off the real-time database, it's easy just to kind of like do your dev cycle just by deploying to the cloud. Yay, it's up. So uploading. 0 new logs. Let it run. It's the first execution, so it'll take maybe a second or two before it triggers. It triggered! And it tells us a bunch of stuff we just printed out. We have our new session state uploading, which is what I changed it to. We have our rig, a foobar, and our session identifier, session01. So the first thing we're going to do is let's make sure that it still ran. Hit live, get the live logs, and hey, it ran much faster this time. A 1/4 second long. And this is jiving with that's exactly what I'd expect to see. We have our uploaded, which is the only state upon which we want to actually take an action. We have our rig ID and we have our session ID. Where did the session ID go in here? I expected to see the session ID next to the rig ID. Oh, there it is. It just did not appear in the live logger. Good enough. So yeah, everything was backwards because the log is upside down. So we'll leave those in there for now while we're doing development, but it's time for us to start adding some actual code that does stuff. So let's add a short circuit, because this will be triggered as the thing walks through its state machine, but we don't really want to trigger on any state except the uploaded state. So if we're triggering on the state, original, refactor, rename. This is the session state. So if session state is not equal to or cannot be coerced into, so we're going to add a short circuit here, and it gives me a warning, and it says, comparison may cause unexpected type coercion. Yeah, that's actually what I want. I want kind of a broad net here. Return. So when I do a short circuit in a function, I think I can just return. I think that's actually going to trigger that. Okay. So console.log, we're going to log a message. So state is, should probably do the variable expansion. Let's see, I haven't actually done this much. Is that with a double quote? Whatever, I'll get back to that later. So we're going to be session state. Oh, I have like mixed use of like camel case and underscore. Let's fix that now. Session state. Session state. State is session state. State is black. No. Exiting now. Nothing to do. Exiting now. Nothing to do. Exiting now. Okay. So unless you have an uploaded state, there's probably a cleaner way to write that so I don't get little warnings. This says return is unnecessary as the last statement of the function. Yeah, just wait. Just you wait, IDE. I will show you. So we're running the giffizer now. We're going to be figuring out the bucket. This is actually kind of like a fixture that I created, like a test object that I created from a storage trigger, which we're not actually using. So that all goes away. We're going to be constructing those paths using something else. We have our buckets, though, which I guess I'll just go define up here. Const. Oh, and these are actually, those buckets are going to be per rig also. I'll just hard code them for now. We'll figure out a better way. Use a config file or something for bucket, because we don't really want anything hard coded. But for now, I'm just going to hard code those buckets. So we have our source bucket, and our source bucket is. It's already in here somewhere. Wait, did I just delete it? I just deleted it. It is giffiator. We're going to go back to our buckets and giffiator source. So we have our source bucket and our gif bucket. Which is giffiator gifs, I think. We're going to go grab this, giffiator gifs. So now I have our giffiator gifs up there. Make sure this stays on the screen. Giffiator gifs. Okay, so we have those two hard-coded constants. The Java developer in me wants to make those all caps. I don't know if that's actually the preferred style. Coding style is hard. So now that we know those paths, we are set up a bunch of temp variables for easier reading. Actually, I'll just grab these and bring them down for now. So they are close at hand. So those are the real constants. Then number of frames, I'll be getting that from somewhere else in the Firebase, because I can read arbitrary locations also and chain them together with the promises. But for now, I'll hard code at 5. Read from written elsewhere in Firebase database, and this is kind of crazy. That should be something like that. Okay. So this is not getting used at all. File bucket, where does this actually get used? Oh, just right there. And then where does this bucket get used? That is just the source. That's what I have kind of renamed to source bucket. GCS.bucket source bucket. Source bucket. So now I have the string representation and the bucket representation of that bucket. So we'll change this to name. And gif bucket to name. Yay! Okay. So then this is the real source bucket. I might as well just make the destination bucket here too. Just for, you know, symmetry. Copy and paste. Then we have our temp directory. So read from elsewhere in Firebase database, read frame count. So I'm probably just going to do kind of a list there. Oh, I could also read this from, or by doing a stat, or doing a list, or by counting the number of pictures in that directory. Which might work. I don't actually know. I need to go through that. And here's our set of our collection of promises that we're going to create. So this is our session identifier. Oh, okay. So we're going to need a way to communicate in the other components of these file names. So if we go into giffizer source, I mentioned that we are going to have these. They're going to have some kind of timestamp with them also. So we're going to need a way to communicate in that, or this function is going to have to figure out how to grab all the ones with the same timestamp. But for now, we're going to solve it the way we solve a lot of these problems. We'll hard code it for now and get back to it later. Camera prefix is just cam 0 for now, because I'll need to left pad those numbers, and then like using printf or something, and then this is actually a source image prefix. Frame? It's a frame. Frame prefix. I should probably just use a format string here, but I don't know how to do that in JavaScript, so I'll do it all crude like, so that I can keep my momentum up, because that's all that matters, right? But a to-do to later. To-do! Use like some kind of format string. Or something. We also need to programmatically handle the left padding. Which I know is an interesting topic in Node overall, because that's kind of spelled right. It's spelled so badly my IDE can't figure out how to correct it. Oh, it was only off a little bit. Which I know is a left padding I know that it was a library of some drama at some point in the Node history, but I don't want to, I don't want to force all of you to watch me do some research. So I'm not. Okay, so we have our source bucket. So this is reading. Okay, so moving on. We're getting back into this thing. So now that we have all these variables kind of set out, we have our... So do we want to add an assertion here? How do asserts work? I'm glad I'm not the only one using Google to fix my spelling mistakes. Oh yes, Google is actually it's got to be one of the best spell checkers I've ever encountered. I don't know how it knows without context. Because you'd think this thing has context. It should know better how to spell things than just a random word in Google. But Google's a wonderful spell checker. And it's funny that search engines solve so many problems with a single strike. Anyway, oh, now we have the problem in that I've said this thing has 5 frames, but it really only has 4. I just did that, didn't I? Well, let's fix that the silly way. We're going to go back to our desktop. We're going to go to our GIF frames, and we're going to copy and paste the 4th frame twice. Because I am an animal like that. So it's actually going to look a little weird because the same frame is going to be shown twice at the end. I guess what might be a little better so we can actually see it change. Instead of that, I'm going to do the second to last frame again. So it's going to kind of jiggle back and forth. So at least now we have 5 frames, so it's an odd number. I don't know why I made that change this far into the stream, but whatever. I did, and I accept that. So now we have this going up. So where are we? So we read the frame count from elsewhere in Firebase. Oh, hey, Slayer Darth. How's it going? We get the frames going up again. So now we need to pull them down. So this is actually going to be the session identifier, which we actually have in a parameter now. Should we store that into a shorter variable name? Yeah, let's do that. We have our rig ID and our session ID. So we're going to grab the session ID. Question is, you don't seem to be in your apartment today, unless this is your apartment and I just didn't notice last time. Too much hardwood flooring. I am actually in my apartment. Yes, I am. I just removed some of the clutter behind me. So it is all crazy blue wall, which my wife actually mentioned I could even use as a chroma key itself. I was able to turn the whole thing around so we wouldn't have as much background. And lots of hardwood floor and the floating chair. And of course my living room hammock, because everyone needs a living room hammock. Living room hammocks are critical for happiness in this modern world. So grabbing my session identifier, which is going to be here, and then we have our image prefix. Yeah, I really need to use a format string instead of this series of pluses like I'm some kind of Java programmer from the mid-90s. We have our camera prefix, we have our frame number, and we have our frame suffix. Oh wow, that's really ugly. Yeah, that could totally be made better with something nicer. And these are going to be downloaded to our temp directory. We have our frame prefix here. We have our frame suffix here, and I'm going to be a little more dry than usual. Let's just call this file name. And that's going to be our frame prefix, our identifier, and our suffix. Okay, this is a little bit less head make hurty. And too much. One should not be asleep when suspended. It defies the laws of physics. Yes, my living room hammock, I don't actually use it to sleep very often, although I did once when I managed to somehow hurt my back pretty good. But usually I just lounge in it. It is a wonderful thing to lounge in. It's like the best $20 I've ever spent at Costco, ever. We bought it with the intent of it being a camping hammock, and it turned into the living room hammock pretty quickly. And then life, like, we never really looked back. Okay, so we actually have stuff downloaded now. Let's see if this actually works. So I'm gonna kind of like comment out the rest of this stuff for now. And it seems like now is a good time to do a checkpoint. So I need to, so a cloud function has to return a promise at the end. So I can use this, if I know right, this returns a promise, yeah, it returns function iterable, and it returns a promise. Okay, so this, I need to return a promise at the end so that Cloud Functions knows when to cease execution. So I'm going to do that. And here too. We are just going to do the download, and we're going to see what happens. So this is the point where we're downloading a bunch of stuff. I think this will work. Let's see if this runs. This seems like a good checkpoint. So we will deploy it so we can do our syntax check in the cloud. Question from Slayer Darth. I don't get the hate behind Java. Coding in Java helped teach me the importance of organizing my import statements and grouping them according to similar libraries, package management, etc. And I totally agree. I actually love Java, and coding on the JVM has been a significant portion of my software development career, between Groovy and Java and JRuby and all sorts of stuff. So the JVM and I are very close. And I generally fall, at least for larger projects, I fall pretty hard into the typed languages, end up saving you time in the end, especially when the number of collaborators increases. And I know Java has a bad rap, partially because enterprise Java and over abstraction is so easy in Java that you just end up over abstracting sometimes, which has downsides, I understand. But you know, any tool is a tool, and tools can always be misused. So I'm just clearing the historical data. My function should be uploaded. So let's give it a kick. So when this changes, something should change. Let's change it to yay, and we should see a short circuit now in our logs. Turn our log into live mode. And there's another question. Is Costco available to the public? In the United Kingdom, for us, Costco is apparently only open to the public on Wednesday mornings. Otherwise, you need to subscribe to their membership scheme. So yeah, so Costco actually, I think it started not too far from me. Oh, here it is, state, exit, yay, nothing to do now. Hey, that's exactly what I wanted it to do. It's like it's still working. I haven't undone any of my previous work. But yeah, so Costco, you do have to buy into their membership scheme, but I live across the street from Costco, and groceries are so much cheaper there, and there's a missing slash. Okay, and then the stuff is pretty high quality, so it ends up being worth it really fast. So I opt into their membership scheme. It pays for itself in like one trip, especially if I buy like a bottle of liquor or something. Okay, so we got a read-only file system error. Cannot open my picture, cam01_1730000. That's because there's a missing slash in my temporary directory. And that is because temporary directories, as they come from that library, don't have that trailing slash. So I need to have that slash there. But hey, this means that it actually like started to run this promise. That's really exciting. That means there are probably not any other big problems on this, and we can kind of keep moving. No, Twitch is messing up, Slayer Darth says. My 1 gig RAM laptop can't handle your 1080p stream. Oh, I am sorry. I have too many pixels, it seems, but I think that's the trade-off for making it making a possibility that my code will actually be legible. So I apologize. Okay, so let's go back to logs. See, the stuff is still running. Are you? Oh, yeah, actually, I haven't actually triggered this thing to do. Back to yay. Back to uploaded. So if this logging is going all happy like, we should see a short circuit message appear. And then we should see the updated message. And hey, the short circuit one is further down here. Let me make this a little bigger. This is the short circuit one. It exited, and then another execution started, and it took a couple seconds before it exited, which means it probably downloaded all the files. Because by default, Cloud Functions run on kind of weenie machines, which is kind of worth it because having a greater number of weenie tiny machines can actually make for more cost-efficient execution. And hey, we ran giffizer, and then it did stuff, but there's no logs because of the way I constructed the download promises. Because I could have wrapped them in another promise so I could stick a log in there too, but I just used the promise handed back by the downloader directly. And Slayeradar says, my Wi-Fi seems to have pooped up. Yeah, Wi-Fi is always the challenge, isn't it? Because when I'm streaming, I actually plug into like a wire. I know, like old times and stuff. Because you never know, especially in dense housing like I'm in, you never know when someone will run a microwave or jam your signal for some other reason. But still, 1080p is a bit too intensive for me. Thank you for the feedback. I may experiment to see if I can get a readable stream, like a viewable stream, with fewer pixels. If it works out, wouldn't it be cool if I could stream at multiple qualities? You know, take advantage of the many cores in my fancy laptop. That would be really cool. Or if there's some way to do like inline downstreaming, like do real-time processing on it, there's probably a startup there. So if anyone wants to go build a startup that does kind of like real-time stream transcoding to multiple quality levels for delivery on different clients, you should totally do it. Anyway, okay, so we're at the point now where our download seems to probably be working, maybe. Let's see if this giffiization can work. So we're gonna be uncommenting our code one chunk at a time. Next, we're gonna try creating that animated GIF. We have this monstrosity, which is still a little bit hard-coded, and we have a to-do to parameterize it. I think once you get enough views, Twitch makes your stream available at lower presets. Oh, cool. So that means if I just keep doing this and keep doing awesome stuff, eventually Twitch may do the lower quality streams for multiple clients for me. So, and then Phoenix Uprising said, I think there is an option for that somehow. Most streams give multiple options. I always figured it was done automatically. I will investigate. This is a research task for between this session and next time. Oh wait, I just realized we only have 6 minutes left in this stream. So I am going to try and get this working. And since I only have 7 minutes left, I'm just going to live on the edge. I'm going to take both of these components and put them together at once. And get this, see how fast we can get this all done. So rather than do one thing at a time in a more conservative approach, I'm just going to do it all at once. What could go wrong? So tempter, so this goes to our destination bucket. We have our GIF bucket, which is already up there. Hey, it suddenly realizes it's available. Scoping, it's a thing. So we're going to do GIF bucket upload. We're going to upload to our session identifier, which is called session ID? Yeah, session ID. We're going to do this backwards. So first, I'm just kind of modifying all this so that it matches up to the new file names and paths we have all over the place. We have our tempter. We have all the images we have downloaded, 1 through 5. And I'm just going to hard code them for now. We have a different file name prefix. I don't know if you can hear it, but the construction is alive right next to me. They are literally tearing down a building next door. It is hilarious. Such are the joys of living in a dense city. So we're going to grab these different frame prefixes. And we're going to super messily hard code all the things. Except now we have 5 frames. So we're going to, I think it's probably time to split these out onto their own line. And later, what I'm going to do is I'm actually going to construct this argument list so it's a little bit less of a hard-coded disaster than it is now. But I think it works sufficiently. Okay, so we have the frame prefix, that, we have the suffix, which is just dot. Oh yeah, I should probably do the whole suffix. So, oh, and the prefix has a leading 0 because I didn't bother to figure out how to left pad zeros before I started the stream today. These get a suffix. So we're gonna grab these, and this one is frame 1. We're going, I don't know if there was that double frame 2 bug in the previous version or not, but I did not notice it. Okay, I think this will actually point to the right files. We'll see. ImageMagick will complain if it does not. Then it should upload it. So this might just work. Let's find out. So I'm going to deploy that function again. And then there are some questions in the stream, which is great because it takes a little time for the Cloud function to actually process. So I can actually talk to people in the chat. So Jen, Slayer Darth asks, so Jen, did you go straight from school into a job, or did you go through college route and then into the world of work? So I did a little bit of both. I did indeed do the university track, but I did lots of internships and working while I was in school because I was in the original part of my university education. And they just trigger this function. We're going to do yay again. I did go to university. I went to Santa Clara University out near here, which is a Pope-approved Catholic school. And I studied computer engineering there. But while that was going on, it was during the dot-com boom, so I took advantage of the fact that there were wonderful internships available to anybody who could breathe a single character of code. And it was a wonderful learning opportunity. Actually, I worked in silicon and robotics during my internships, which was a great opportunity to learn something I didn't want to do, because at least at the time, I did not enjoy robotics all that much, because the tooling was just not as good. And that's actually how I discovered a love for Java, because Java debugging and all that stuff got me hooked on the JVM. So I actually spent a lot of time writing enterprise code just after I graduated from university. But I already had a few years of work under my belt, which is a great way to try and get some of the student loans a little smaller. Student loans are a big thing out here in the States. They are crippling debt. And dot-com boom internships were a great way to get a leg up on that. So ImageMagick got grumpy. Spawn, ent, Magic got grumpy. Why did Magic get grumpy? Exports, handle on exit. Basically, ImageMagick failed to spawn. And there is a clue back to this. Maybe the magic command is not running. So I don't really know how to get the standard output of that command, or the standard error specifically of that ImageMagick command. So let's just tinker with it a little bit, see if we can get it working. So one thing I remember seeing in the example is instead of running the magic command, they ran the convert command. Let's just take a wild swing and see if that fixes it for whatever reason. And then let's just trace through this again. So we have our temporary directory. We have that slash that we played with last time. We have our file name prefix. Cam 0, 1, 2, 3, 4, 5. We have the 5 frames that got downloaded, probably. We have the frame suffix. Those are the .jpegs. And then should be able to write out to tempter/spin.gif. Okay, so that, doing the rubber ducky approach and talking through it, that seemed to work okay. And then tempter, okay, I don't see any obvious bugs, and nobody else is cluing me into an obvious bug I've created. So let's just hope that it was something that small, which is a little puzzling why the convert command works and the magic command doesn't. But if it works, I can investigate that later. Yay, nothing to do. That was that trigger. And then the next trigger should be coming down the pipe in just a second. It's running the giffizer. Stuff downloaded, probably GIF time. It's looking good so far. It hasn't crashed yet. You should have a GIF. Finish execution, 16.7 seconds. Yes, we will definitely need to do that in parallel. And if this worked, we should have an image in this bucket, a GIF, if you will. Maybe a GIF. And there it is, a 500 kilobyte GIF. So let's click on this and it'll bring it up in the browser. And hey, it is the GIF. And it's the GIF without that weird frame 3 doubled again just after frame 5. Lots of extra frame stuff there because I did terrible things to get these frames for our development tinkering. And it works. So that's pretty cool. We now have this running as a cloud function. So I wonder how long it takes to run the second time. I'm just a little curious. I'm going to do one thing before I call it a day. I'm going to trigger this execution again to see if it is faster on the second execution. See if it just took a moment for that function to warm up. Let's tell it to start live logging again. It turns off live logging when you tab away for too long, just because otherwise this is going to make an expensive thread on your browser and use up your system memory. And you don't want that. Memory limit exceeded, function killed. Okay, so that means I need to tinker a little bit with it. So you can actually change the machines you use for cloud functions. Let's go find them. They're under, if you go to so right now I switched over to the Google Cloud Platform console. And we can see our cloud function. And we can edit it or something. Yeah, we click on it. And we can actually change the machine it uses. So right now it's using 256 megs of RAM, which is apparently too little for my little example. And I'm going to increase it since I'm like, cloud functions really aren't supposed to be used for like video transcoding and GIF making. So the default settings are okay for like 99% of cloud functions you build. But I'm doing more heavy lifting than typically happens. So I changed these up. And these values, although I went into a different console to change these values, they stick between deployments. So let's try that again. We're going to do uploaded. We're going to go back to our cloud function log, turn on the live logger. Oh, 93 milliseconds. Okay, so it's much faster now. Yeah, it's much faster than it was last time. 3.9 seconds. Finish with status connection error. Okay, I'm not sure what's up with that. But did I get my GIF? Oh no, it's trying again. Connection error. Okay. Hey, finished last time. So it tried a couple times. I don't know what's up with these connection errors. Maybe it's because I changed the settings on this and it kind of added a little bit of wonkiness. Anyway, that's something to investigate later. But it did actually retry until we got our GIF, which is pretty cool. So that means if I go back to storage, I should see the GIF in there again. So we're going to go to storage, we're going to go to browser, go to Giphy GIFs, and yeah, there's the exact same image. It's going to look just like it did a moment ago. Yay! Okay. So I believe it is time to wrap up for the day, but before I do that, I'm going to commit my code now in Cloud Functions for Firebase form with GIFs. So we're going to commit that, and then we're going to kind of do a quick recap on what we did. So we made it right to the real-time. Okay, so earlier today we cleaned up some of that terrible hard-coded mess. And my promises are slightly less embarrassing now. I'm still pretty new to them as kind of a design approach, but I dig them. I understand why they have gained as much popularity as they have. And then we wire them up to the real-time database. So we set up a trigger where it triggers on a write to the real-time database, like a source trigger, which is a change in the state machine of the recording session, which is based on a bunch of fixture data we stuffed into there that'll eventually get populated by the mobile apps. And then we have a done trigger, which I did not actually do yet. So once it's done uploading, it uploads the GIF. The GIF might be a good enough done trigger. We'll see if the downstream systems are fine with that. Because the next step is to upload, because like what's going to happen eventually, there's going to be like a cool console that kind of watches this GIF creation, because it does take a few seconds. So we'll consider this done for now. So I'm going to format, I'm going to strike this all through. And actually, our GIF function's pretty much done now, which means next session, I'm going to move to a different component of this demo, probably the frame extraction. Because what happens is we record, we're actually recording video clips on all those phones, and we're extracting video frames that we use to construct these GIFs. So I'm going to be using FFmpeg next week to extract the frames from those video clips so that we can use them to create the downstream GIFs. So there was a question from Phoenix Uprising. Do you already have a mobile app to take pics and upload them to the bucket? Yes, we do. So that was actually written by my wonderful intern who just finished his internship. GitHub. And it is already open source in apparently, oh yeah, here it is. Actually, I'm just not logged in right now. So the GitHub webpage looks a little weird. So Hassani already implemented this, and there actually is already an Android app. There are 2 Android apps. There is the app for Cloudspin v2, which might need to be renamed, which is the app that runs on each one of the little phones that does the the video capture. And then there's another one which is intended to be run on a tablet, which is when you run into a photo booth and you hit that button to say go ahead and take my photo. That is kind of a single controller app that tells all the other phones when it's time to take the video clips. Those are already implemented. Hassani wrote them and did a great job. There will probably need to be doing a little bit of tinkering on them to get them to jive with all the functions, because we worked in parallel on these 2 things. And we talked a little bit about a specification for the data interchange, but I imagine we'll probably be doing a little bit of massaging to get it right. So you can already look at that code. It's already available on GitHub at cloudspin, which is where this function will be uploaded later. It is licensed under the Apache 2.0 license, copyright Google. So go ahead and poke around if you like. So on that note, I will be finishing up for the day. Thank you so much for joining me, everyone. It is so much more fun to do some coding when you have friends in chat. So I will talk to you all later, next week or whenever. Bye, everybody.